Hello again, Year 12. Today we're going to have a look at dot point 9.2.2.3. Compare the structure of arteries, capillaries and veins in relation to their function. So first thing that we need to do is unpack the dot point, okay? So our key word here is to compare. And when we compare, we look at the similarities and differences. So we're looking at the similarities and differences between the structure of arteries, capillaries and veins, and then relating this to their function, okay? Why do they have different structures, and how does that particular structure actually help them carry out their job, basically? So just a few little facts about the cardiovascular system, which is made up of veins, arteries, capillaries, and what pump blood around our body. So the body contains 20 major arteries. They carry blood away from the heart, and it's normally oxygen rich, all except for the pulmonary artery. So arteries branch into smaller arteries, essentially called arterioles. Arterioles then branch into even tinier vessels called capillaries. Capillaries deliver oxygen and nutrients to cells and pick up waste. Then capillaries join together to form venules. Venules form together to form veins, and veins carry mostly oxygen poor blood back to the heart, except again for the pulmonary vein. So another fact, if all the vessels in your body were laid end to end, they would extend about 96,500 kilometres, so they could go around the earth twice. It is also a known fact that if you get all the blood vessels out of somebody's body and tie them all together, they will die. So our blood vessels are very, very important in keeping us alive. Alrighty, so the blood vessels that carry our blood around, again, are called arteries, veins and capillaries, okay? Arteries and veins have a bit more of a similar structure than capillaries. They are still different, but those two in particular are a little bit more similar. So both arteries and veins have a lumen, which is basically the hole inside the actual blood vessel. And they also have a wall, so essentially the bit surrounding it. And the walls are made up of 3 layers. The outer layer of connective tissue, a layer of smooth muscle tissue that has lots of fibre inside that, and then an inner endothelial layer. So let's look at arteries first. Arteries carry blood away from the heart, okay? And a good way to remember it is A with A, okay? So arteries carry blood at very high pressure from the heart so that it ensures that blood can reach every single part of the body. So it's a fair distance between your heart and your toes, so the blood needs to be at very high pressure to get it all the way down there, okay? So arteries have their thick layer of muscular elastic fibres, okay? That layer in particular is really thick, and that allows them to expand with each heartbeat, and that causes, each heartbeat is causing a surge of blood, so they can expand, okay? So the elastic bit allows arteries to stretch with this high pressure, and the muscular bit let them push blood along to all extremities of our body, okay? The other important feature of arteries is that they have a reasonably small lumen. So remember, the lumen is the hole, the opening that blood actually travels through. They have a relatively small lumen, and that helps blood flow at high pressure, okay? So it's a little bit similar, you've probably all done it before. If you're running a hose and you pop your thumb over 3/4 of the opening of the hose, the water starts to spurt out in much more pressure, okay, because the hole for it to get out is smaller. And essentially it's the same thing. So having a small lumen or a small hole for the blood to travel through keeps that blood flowing at high pressure so it can get to every area of our body from the heart. All right, next one we're going to look at is veins, okay? So veins carry blood back to the heart, all right? Blood travelling back to the heart is at a much lower pressure to blood travelling away from the heart, okay? So because it's at such low pressure, veins have a wide lumen and a thin layer of muscle and elastic fibres. Sorry, that says thick and it should say thin. A thin layer. A thin layer of muscle and elastic fibres, okay? They don't need to be able to push at such pressure. But because blood's flowing back to the heart, in most areas of our body, that actually means that blood is moving against gravity. So there's a risk of backflow and blood moving in the wrong direction and pulling at our toes, basically. So another important part of veins is that they contain valves, okay? And valves prevent backflow. So if you have a look here, the blood flows through the vein. Gosh, I'm getting my tongue twisted. The blood flows through the vein and it pushes the valve open, okay? Valves can actually only open one way. So once the blood has gone through, the valve closes back over, and even if blood in the vein does get pushed backwards a little bit from gravity, it can't go very far, okay? And it does still get a little bit of pressure with each pump of the heart, so essentially it can travel through some valves then with each pump, and then when there's not a pump, it stops the blood flowing backwards through the body, okay? And as you can see here, like I said, much wider lumen, so wider opening for the blood to flow through, doesn't need nearly as much muscle tissue or elastic fibres in it. Right, so now let's check out capillaries. Capillaries are what actually get the blood to and from our cells, okay? Our individual cells in our body. So capillaries link arteries and veins together, but they're actually the only blood vessels where the substances can be exchanged between blood and our body cells. So they have really, really thin walls. They're only made of one single layer of cells, and it has a very narrow lumen that can only let about one blood cell travel through it at a time. So the reason that it's so thin and doesn't let many blood cells travel through it is because that actually allows diffusion of substances between the blood in the capillary and cells, okay? So there's a lot more exposure to each other. So that means that oxygen and nutrients and things like that can be delivered to the body cells through diffusion, and carbon dioxide and waste and other things can then be delivered back to the cells to be able to get rid of, okay? So here's a bit of a diagram, and I'm going to go through a few quick rules in terms of writing or drawing scientific diagrams, because it is a skill that you need to be able to have, and it will come up quite a bit in this course. So I've popped, these are actual slides of artery, vein and capillary, okay? So you can see the difference really clearly between the three structures when they're all compared, okay? So in the artery, the smooth muscle and elastic fibres layer is really, really thick compared to the vein where it's not particularly thick. And the other thing is the lumen of the artery is much smaller than in the vein. So there's a bigger opening in veins for blood to flow through. And here you can see in the capillary, it's very, very thin. It's only one cell thick, okay? So some important things when drawing scientific diagrams, you need to make the lines nice and clean, okay? By clean, I mean not feathered and things like that, so it's not so much sketching with bits sticking out all over the place. The lines need to be very sharp, okay? Another thing you should note is that you should always have a title, and another really important thing which people tend to get carried away with often is that you don't shade in scientific diagrams, okay? If you want to show a difference between different things, you can do lots and lots of little dots or little lines like you can see on this one, but we don't actually shade or colour in anything on a scientific diagram. Obviously, they always need to be done in pencil, okay? We label using straight horizontal lines, so we draw a line to what we want to label, draw a straight line out, and along the side write what it is, okay? So just a few little pointers to keep in mind, because we will get you to draw a diagram of each of these blood vessels. So just to summarise it all, we're going to get you guys in class time to basically do up this table, okay? Now, just so that you're aware, this is not to scale, okay? I just had to try and fit it all on the one page, and that should say composition of blood, and for some reason it's cut it off, so I apologise. But you will need a bit more room for your diagram, probably for your definition and stuff as well, okay? So just keep that in mind if you're actually going to draw it up in advance. Leave some extra room for the diagrams and things like that. Okay, so that has pretty much summed up the structure and function of blood vessels. So enjoy.